And we're continuing on with our card example. Now, chapter 13 gets into objects of arrays. It talks about in this chapter, we take another step toward object-oriented programming by defining a class to represent a deck of cards, and we present algorithms for shuffling and sorting the arrays. They give you the code, they say there. Okay. Main idea of this chapter is to create a deck class that encapsulates an array of cards. So initial class definition looks like this. So over here, you right-click on this package here and do a new Java class. And call it deck. And then click finish. And a private and a card and cards. Now this card you see right here, the uppercase C, that is referring to this class. Remember when we broke it down and defined an individual card? And then this little c, cards, is just the name we give it. And the brackets here indicates an array. So got a bunch of cards, so an array of cards. Now this down here is just the constructor, and they pass in. It's in. And they say this dot cards is equal to new card in. Okay, now this is our constructor. Again, how I know it's my constructor, the name here matches the name of the class. And there's no nothing like a void here, int, nothing's returned, it's just constructs the instance. They're passing in, which appears to be the number of cards. So if they pass in 52, then it'll create a deck of 52 cards. If they pass in 26, it'll create a deck of 26 cards, and so forth. That's what it appears like, but we'll see. And then this cards refers to this array, and then the new is creating a new instance, and so this dynamically sets the number of elements in the array. Let's see. Constructor initializes instance variable with array, but does not create any object cards. Here's a second constructor that makes a standard 52 card deck and populates with the card objects. I can type all that in. I'll copy that. Remember, you can have multiple constructors. So this one isn't taking any parameters. It does this dot cards equals new card, and then hard codes 52, which isn't a bad thing, because if you look at a standard deck of cards, it always has 52 cards, excluding jokers. They're always the same. Set the index equal to 0. And this is looping through all of our suits. Remember, we had 0 is clubs, 1 is diamonds, 2 is hearts, and 3 is spades. This is looping through all the elements of our each suit. I think 1 was an ace, 2 was 2, all the way up 10 is 10. 11 was probably a that out of the way. 11 was a jack, 12 was a queen, and 13 is a king. So it's going through and looping through all the suits, through all the cards, the ranks, and then it's assigning these cards. The index refers to the array that I have here. So 52 cards, this is looping through from 0 to 51. So again, we have to remember it starts at 0 in terms of the indexing here. Okay, and then it's creating a new instance of each card. And that new card, the card there is defined over here in our constructor. Yes, it would. Because you have one instance of a deck, and then you have 52 instances of cards. So yeah, it can be embedded like that. Okay, we can now create a standard deck by doing this deck equals new deck. And guess I'll just create it up here at the top. We're gonna clean that up some. This deck with a big D, that refers to our object, our class we just created. This is whatever you want to call it. A lot of times they go with the convention of a lowercase d here versus an uppercase D here. I don't know. I have mixed feelings about that. Sometimes I think it gets confusing. Deck equals new deck. But if you're comfortable with it, then that's often a standard to use. And then equals new deck right here is our creating an instance. And like you indicate, when it creates the instance of the deck, it's creating all these instances of the cards automatically. Now that we have a deck class, we have a logical place to put methods that pertain to decks. Looking at the methods we've written so far, one obvious candidate is print deck. I don't say where to put that, but looks like a deck code. So come here. Now, what told me that it was supposed to be in a class is because of this. You would not have the this typically in your main driver program. And then I had to think where cards was declared at. And cards was declared right here. So this is looping through all of my cards. Notice it refers to the length. There's 52 cards in the deck. So the length is 52. So it's going to I is less than 52. So this is looping from 0 to 51. And it's just printing out all the elements of the array. Section 13.2 talks about shuffling the decks. It says for most card games, you need to be able to shuffle the deck. That is, put the cards in random order. We're going to see how to use random numbers to do this. Now here's some pseudocode. What you do with pseudocode is you try to wrap your mind around what do you want to accomplish. So for each card, for each index I, choose a random number between I and the length of -1, and swap the ith card and a randomly chose card. For example, I think clubs was 0, but let's see. No memory. Clubs is 0. So clubs is our first one. So we have a club ace. We have a club 2, club 3. Up to 10. Then I have a club jack, club queen, and a club king. What they're talking about on this is you're going to loop through, get to the right page. You're going to loop through I and, well, you start at I. And so we start with our first one here. So we start here. Then it says choose a random number between I and length of -1. Swap the ith card and a randomly chose card. So we'll pick a random number. Let's say I get 9. Now, interestingly enough, they say choose a random number between I and length -1, which means in theory you could choose a random number of 1, which means the card doesn't move anywhere. But let's say you pick 9. So then they're saying here, swap the ith card and a randomly chosen card. So the card we're currently on, and then the 9th card, this one down here. So this becomes CA, and this becomes C9. Then you go down to the next one. And again, you pick a random number. Now we're picking a random number between 2 and the length, -1. So you can't pick 1. It'll either be 2 through 13 in my example. Let's say I pick 11. That means I'm going to swap this card and the one down here. So the CJ, this becomes C2, and this becomes CJ. Now that's the idea of what they want to accomplish with this. And a person say, well, that may not be random when you do that. Well, it may not be. I expect it'll probably be pretty good. But if you think about when you're shuffling a normal deck anyway, do you shuffle it just one time? No, you shuffle like 5 times. So if you have this written correctly, you could call that 5 times if you really think it needs it. I think the random numbers would take care of it. Let's see. See if there's anything else there. Then they have a selection sort. Now that we messed up the deck, we need a way to put it back in order. There's an algorithm of sorting it that is ironically similar to the algorithm for shuffling. It's called a selection sort, because it works by traversing the array repeatedly and selecting the lowest or highest remaining cards each time. During the first iteration, we find the lowest card and swap with the card in the 0 position. During the ith iteration, we find the lowest card to the right of I and swap it with the ith card. Find the lowest card at or to the right of I, and swap the ith card and the lowest card found. So it would search through, and for this card here, it'd go through and find the one smaller than it, and then it'd swap them. Then it'd go to here, and it'd find the next one that's smaller than it, starting there, and it progresses like that. Again, they're not going to look like they're going to write these. They just talk about it. So I may just write one of them. We may do the random part, because I don't want to spend 2 weeks on writing all these. Let's do the random part, since I got this kind of already defined here. So we need to figure out how to pick a random number. And we're going to loop through from I to length -1. Okay, so let's come over. And let me see, that should be in my deck because I'm shuffling my deck. So public void shuffle. For int I equals 0, continue while I is less than this dot cards dot length. That's a length -1. I plus what? And I need to find how to do a random number since I forgot. All right, I kind of memory. Random number. I can look in the book, but I expect I could probably find it easier here. D zone. This looks like it here. Random number within a given range. That sounds like it. So come over here and paste that in. It's a strange thing they have coded here. And what did I do? Get rid of my brace? Okay, that's that one. Those match up. I got an extra one there. Um, I think I necessarily like what they did. Um, so if I pass in 1 and 5, for example, it does 5 minus 1 is 4, plus 1 is 5, and multiplies that times this, then adds the min. I think that should work. Um, I say I think, but let me think it through. Max equals 5. Min equals 0. So max minus min, 5 minus 0 plus 1. That's going to give us 6. Um, I think the int does a truncate when I do the cast there, so I think their code is right. So then here, I want to get a random number. So get random integer between the range. And I want to choose one between the current index, which is I, comma, and then my length, minus 1. So this dot cards dot length minus 1. And I want to assign that to swap. So that's what I want to swap. Now I need a temporary location. This is going to be my I. I don't need I if I do that. Yeah, I do. I'm thinking something wrong. So I need my temp. This is going to be my current value at the ith position. So this will be this dot cards I, except for it's a card. If I have to create I thought I might have to create an instance of it first, but no, I didn't. I'll clean this up a little bit afterwards. I'm just thinking it through now. Okay, so I've copied off that card I'm currently on. So then this dot cards of where I want to swap it to, or by, is going to equal to this dot cards swap. And this card swap is going to equal to temp. Okay, so int swap card temp. Well, let's try that and see what we get. So I just create my new deck here. And then I want to say deck dot shuffle. And then deck dot print. And I don't think I need any of this anymore, but I'll leave it there just in case. So now let me run it, see if I'm even close. Four of clubs, 10 of clubs, three of diamonds, jack of diamonds, clubs, clubs, hearts, clubs, spades. These are based upon other ones we're printing. So it looks like they're working. To fully test it, I'd want to go through and verify that I still have every card in the deck. I'm not going to waste time on doing that. But if I was this was a real world application, I'd want to verify that. Is there any questions on what I did there? Okay. And actually, it probably wouldn't be that hard to do a selection sort. So now that we have messed up the deck, we want to put it back in order. Why do you want to put it back in order? I guess let's start a new hand. Okay, so let's take a look at that because that's a pretty easy one too. Public void. New deck. Order cards. Order cards. Well, we're still going to be swapping cards. So I'm going to record off the swap integer. That's the index of where I want to swap it with. I need a temporary card to put it there. And then I'll loop through my deck for int I equals 0. Continue I is less than I don't think that's right, but we'll go look at pseudocode. For each index I. It'd probably work, but I don't need to go to my last card because if there's my last card, there's no cards after it. So I think this should actually be -1, not go to each I. But it should work anyway, based on how I'm going to write it. Okay, so I'm envisioning sitting on the first card. I is equal to 1 or 0. Now I'm going to loop through the remaining cards in the deck and see if it's less than what I have. So I'm going to have for int j is equal to 0, or not 0. J is equal to I plus 1. Because I'm sitting at I, and I want to go to the next card and then go to the end of the deck. J is less than this.cards.length, and then J plus plus. So then that'll start at J is equal to 1 and go through J is equal to 51. And I need to check if it's less than what I have at the current position. And that's the hard part right there. And I'm going to steal their code because they had that somewhere and I ignored it earlier. Tracing the code. Returns 1 if this wins, -1 if that wins, 0 if they're equivalent. This is a code we want. I'm not sure if I know how to interpret whether it's -1 or 1, but that's easy enough. We'll play with it. Okay, so that should be in our, let me think. This is referring to cards. So that should be in our cards class. Maybe I put it in here. Oh, I put it in here already. Never mind. So I do a compare to. So here I need to check if the current card, if this dot cards of I dot compare to this dot cards of J. Is equal to -1. Equal -1. You know, it either be -1 or 1. I can sit there and try to figure out the code, but why waste that amount of time when just try one, see if it works. Okay, so then I'm going to swap them. So I'm going to say my temp is equal to cards I, or this dot cards I. Then this dot cards I is going to equal to this dot cards this will still work. There's a more efficient way to do it, but J. And then this dot cards J is going to equal to temp. I could loop through all of them looking for the one that's lowest and then do the swap after the for loop. This will swap everyone that's lower. And now that I'm talking about that, I think that's probably not the most efficient. Okay, so let me come down here and move these down to here. And all I want to do at this point is record off. Of course, this won't necessarily be the smallest. Because if it keeps on going down, yeah, I think I want it the way it was. Okay, so it doesn't appear like I need to swap. And then swap that. It'll keep going. Eventually, the smallest one will be up there. I think that's everything there. Order cards. We'll see. If it runs forever, then we'll know. Okay, I shuffle it. Maybe I'll shuffle it a couple times. Shuffle. Then I'm going to print it, and then I'll order the cards again, and then print it. Not quite right. Looks like the right idea, except for it's going in the wrong order. King, Queen, Jack, 10. So obviously I did not interpret the -1 and 1 correctly. So let me put a 1 there and run it again. Ace down through king, ace down through king, ace down through king, ace down to king, and I'm not sure why this says queen of diamonds. I'm hoping that was some of the. Oh, that's from this. Do you start seeing the power of objects after you got them defined? If you're writing a game, you never have to for a standard card deck. You never have to write that again. You have got that now defined over here in your card and your deck and so forth. And you this applies across languages. If you're in C#, same principle applies there. You now have this object, this class you've created, that you can just bring in any program you want. And if you want to shuffle it, then you can just call it shuffle. If you want to put it back into order, you just call the order cards. Objects can be viewed in some areas like, why do we even need it? When you get to game development, it just is so vital. Let's see, back to where I was. We just shuffled it. We just did a selection sort. What's a merge sort? It's a simple algorithm, but it's not very efficient. Yeah, that's what I mentioned. But we're happy with it. But if you're curious, you can go through the merge sort, more efficient way. I might even argue that the bubble sort's even more efficient than the selection sort. But okay, I'm not going to do the merge sort. This talks about merging decks. I'm not going to worry about that. Again, deck almost. Don't worry about that. Okay. I really want to finish the book up today. It says, now that we have classes that represent cards and decks, let's use them to make a game. Crazy Eights is a classic card game for 2 or more players. Main objective is to be the first player to get rid of all your cards. Here's how to play. Deal 5 or more cards to each player, and then deal 1 card face up to create a discard pile. Place remaining cards pile down to create the draw pile. Each player takes turns placing a single card on the discard pile. Card must match the rank or suit of the previously played card or be an 8, which is a wild card. When players don't have a matching card or an 8, they must draw new cards until they get one. If the draw pile ever runs out, the discard pile is shuffled, except for the top card, and becomes a new draw pile. As soon as a player has no cards, game ends, and all other players score penalty points for the remaining cards. 8s are worth 20, face cards are worth 10, and all others are worth their rank. To implement this game, we need to represent a deck of cards, a discard pile, a draw pile, and a hand for each player. And we need to be able to deal, draw, and discard cards. Hands and piles have different sizes. Their sizes change as the game progresses. Talks about deck may not be the right way to represent hands and piles. I'm not sure why. Solve this problem by replacing the card array with an array list, which is in Java util lang package. Array list is a collection, which is an object contains other objects. I wonder why you wouldn't want to. So I think that you could, if you're doing a crazy eights. But I never have written the game Crazy Eights, so I'm probably wrong. But I think you'd want your standard deck like that. That's which one's that? That's this one right here where it populates it. And then your one where you're passing the number would be like my hand, your hand, and discard pile. These would be nothing in them to begin with, unpopulated. And then as you pass out cards to players, you would need to get rid of the card in here and add it to these. But we'll see how they do it. Okay. Solve problem. We use a language feature called inheritance. We'll define a new class, card collection, to represent a collection of cards. Then we'll define deck and hand as subclasses of card collection. Subclass is a new class that extends an existing class that has attributes and methods of existing class plus more. We'll see details soon, but let's start with card collection. Okay. So here's our card collection. And says when you declare an array list, you must specify a type it contains in angle brackets. So you got your less than, greater than, and it's a card. This declaration says the cards is not just an array list, it's an array list of card objects. If you've worked with C# at all, you've seen that notation. We got less than, the card, then greater than. And we're going to deal a lot more with array list, or not a lot more, but we'll deal more with the array list in the other book. Then down here, array list provides a method add that adds an element to the collection. And so we'll write a card collection method that does the same thing. So you add card, and then this dot cards dot add, and adds the card in. Keep in mind, the cards we're declaring is right up here. And so that's going to add in a card. Now, says until now, we've used this explicitly to make it easy to identify attributes. Inside add card and other instance methods, you can access instance variables without using this keyword this. So from here on, we'll drop it. Over here, and a lot of these were referred to this. You see, if I take it off, it works just fine. It's not technically necessary. For me, it helps wrap my mind around it because this, I think of it, it refers to the current instance of the object. So this instance dot cards is equal to this. But you don't have to have it. Again, it gets confusing when you got everything named the same, though. So I think this kind of adds to the understanding. It says we need to remove cards from a collection. And so we do cards.remove and remove it at that position. And if we're dealing cards from the deck, we don't care which card gets removed. It's most efficient to choose the last one, so we don't have to shift any of the falling cards. And this is a pop card. So it goes to the size of my array minus 1. This is the last card. And it does a return and then pop card. Okay, they just want this so you can pop it off of any position. I was wondering why they just didn't when you do the pop card, instead of having to call it another pop card, you just have it you call this passing in the size minus 1. Notice the pop card uses card collection's own size method, which in turn calls the array list size method. So that's what that's referring to. Empty method that returns true when size is 0. So I guess if it popped all the cards off, there's nothing left in the deck. That's what that's checking. Methods like add card, pop card, and size invoke another method. I'm doing much additional work called wrapper methods. We use these wrapper methods to implement less trivial methods like deal. So instead of you putting this in your code, then all you have to do is call this empty. Sometimes you wonder, well, why would I want a method for one line of code? Just so you can easily program it. Like I did over here. When you get to the programming, there's no thought process behind it. If I want to shuffle the deck, I do deck.shuffle. If I want to print it, I do deck.print. If I want to order the cards, deck.order cards. So instead of having to remember what the check for cards.size is equal to 0, you just check to see if it's empty. Let me see. This one's looping through. Okay, so it's passing in. Like I'm gonna deal you 5 cards. And you need to know what card collection you're gonna give it to. Like it'd be you or me. So then this is looping through I equals 0 while I is less than 1 or in. And it's popping off those 5 cards and adding them to your deck or to your hand, I should say. Now, if you ever played any kind of card game, what's wrong with this code right here? Right. If you or the same card. Well, it can potentially give you a wrong amount. It all depends upon the game you're playing and how many cards are left. But just for the Crazy 8 example, it works just fine in that regard. For example, if at some point during a card game, and I don't play very many card games, pitch is it. But if you're having to deal from the deck at various times, you may not have five cards times however many players. And this doesn't check for that or anything. It just automatically starts popping them off there. That's one issue. And the other issue is I played pitch this last weekend, went over to my brother's house. We went to Lawrence and visited with them. And was it 9 cards you hand people? I think it's 9 cards you give people. And you go, here's a card, here's a card, here's a card to the individual players. You don't automatically just give 9 cards to the first player, then 9 cards to the second player, then 9 cards to the third player. I don't know why, but that's just not usually what it's done. Not that it matters. If it's truly randomly shuffled, then it shouldn't matter. But anyway, just things to comment out there. To access the elements of an array list, you can't use the array operator, the brackets. Instead, you have to use the methods get and set. So you see here, return cards.get I. And to get the very last card, this goes to the current size of it, -1, and gets that card. Swap cards, they give you a code here. So I and J, you have to have a temp card like I created. And so then that stores that off. Then you swap I and J, and then you put temp in for J. And here's random.nextInt. I did it the hard way. I forgot that. Random equals new random, and then you're looping through there. This gets your next integer, and you swap the cards. So this is the shuffle code that we looked at. Okay, so at this point we have a class that represents a collection of cards. Next we use it to find deck in hand. Here's a complete definition of deck. Notice the word extends here. First line uses the keyword extends to indicate deck it extends the class card collection. That means a deck object has the same instance variables and methods as a card collection. Another way to say the same thing is that deck inherits from card collection. We would also say that card collection is a superclass and deck is one of its subclasses. Some of you have seen this example, or something similar anyway. We have the Animal Kingdom. Underneath the Animal Kingdom, boy, my biology is very weak. Say we have mammals. I don't know if that's the proper breakdown. Under mammals, we have humans. Now, there's things you can define at the animal level. Like maybe you can define all animals have an age. And there's better examples than this. Heart rate. Now, when I go to define a mammal in terms of a class or an object, I don't have to define age because it's already defined at the higher level. So maybe a mammal, I then define I don't know, number of I don't know what a mammal is. But if I go to the human level, I know what human is. Human has a name. I don't have to declare an age because that's declared at a higher level. So we're talking about this. The deck extends card collection and talks about card collection is a superclass. So in this example here, mammals extend animals. The animals are superclass and the mammals are subclass. And humans extend mammals, which by default extends from animals and inherits all the classes, the class variables you defined, all the methods, and so forth. Does that make sense on the inheritance and that those terminology? Okay. And if you've defined it right, it just makes your coding so much easier because you're not doing a lot of repetitive definition or anything. Now in the instance or the constructor, where you create an instance, notice that's public deck, and that's what we call it up here is deck. Now here we got a super, and this is referring to the card collection. Remember up here, we had our constructor where we passed in a label. So that was our constructor for the card collection. So then down here, when we do super, that's doing a constructor of the card collection and passing in the label, the string we passed in there. And then we got our looping through here where we create all our instances of the cards. Let's see, has the same instance variables, methods as card collection, inherits. Okay, talk about all that. Constructors are not inherited, but like all other public attributes, methods are. The only additional method in deck, or at least for now, is a constructor, so you can create a deck object like this. The first line of the constructor uses something new, super, which is a keyword that refers to the superclass of the current class. When super is used like a method, as in this example, it invokes the constructor of the superclass. Just what I said. And again, it doesn't do a whole lot, but it does some essential pieces. Initializes the attributes label and cards. When it returns, a deck constructor resumes and populates the cards. Notice here we have another hand extends card collection. And in the constructor for the hand, we then call super. And that refers to our super class, the card collection constructor. And then display here. Okay, that just prints out all of our cards again. Let's see, deck equals new deck, hand equals new hand. Again, by default, when you do this, it does all that in the background where it's referring to the super class and so forth. Shuffling the deck. Here's how we deal 5 cards. So hand doesn't have anything to begin with, but after this is done, then it has 5 cards in it, and then displays it. If you've done your objects correctly, you see how easy your coding is down in your main program? If you want to deal somebody 5 cards, then you do this. Here's your draw pile, and you're giving it a name. And deal all. I'm trying to remember what deal all was. Kind of implies you deal all the cards. Which deals all the remaining cards. Okay. Yeah, I forgot. Draw pile has 47 cards. Of course, if you run this example, you probably get a different amp because the card is shuffled randomly. If you're a careful reader, you might notice something strange about this example. Take another look at the definition of deal. It's supposed to be a card collection, but we invoked it like this. Hand, new hand. Oh, okay. I see what it's talking about. I was going to say, because the hand is defined with the inheritance. Okay, argument is a hand, not a card collection. So why is the example legal? It's because hand is a subclass of the card collection. So hand object is also considered to be a card collection object. Does not work the other way. Not every card collection is a hand. You think about it, not every animal is a human, right? But every human is an animal. Anyway, they come up with a player, and the class has a name, has a hand associated with it. Here's your constructor. Pass in a name, and then it gives it a new hand. And it's just a new instance given a name. Card play, eights, card previous. Search for map. First prime is a reference to the 8's object that encapsulates the state of the game. We'll need if we have to draw a new card. There's a card on top of the previous pile. I don't think I understand that code. I'd have to look at it for a while longer. I'm not going to have time to explore it in class here. Oh, that's right, because it's been so long since I played Crazy Eights. I never played it with a regular deck. We had a special card deck. It had like clowns in it. I remember that. Oh well. You get the idea behind that. I'm not going to go through all the rest of those. Oh, here's 8's class. More than I have time to go through. But you get the idea of inheritance, which is what I wanted you to get out of that. Here we have your card collection, which is an array list, and this really shows it. And then you got hand and deck that are both card collection. And then over here, you have your connection between your player and the 8's, the hand. Not sure about the 8's again. And we're done with that book. So on the next class, we'll get into the next book and start exploring topics in that. And some of this I went through fairly fast today, like the array list. We'll explore in more detail. So, is there any questions on any of that? Okay. And I know Kyle, you're interested in game development. You could use this same code they have here and create a game in Unity. The fact it's Java doesn't change the fact that if you have these definitions of classes created, then you got your code already assigned, and you can use prefabs to drop the code, onto prefab and have it all handled automatically. Well, we'll go ahead and stop there. I'll go ahead and stop the recording.